Hi everyone, I am back and today I'm going to try something new and I won't be programming in Python, but I will tell you a short story using a few slides. So, to be more specific, I would like to talk about network science, which was my major subject during my PhD years, which happened quite a few years ago. I believe that if you allow me for that personal note, it happened between 2016 and 2020. So there was quite a few years in my life where network science played the most important role. So let me just zoom in and start to share this story with you. So network science is a very interesting and interdisciplinary field. In network science, there are researchers and professionals who are coming from the STEM background, but also the humanities are there. For instance, a network scientist can come from the physics background as myself, or computer science or mathematics, but a network scientist just as likely to be a sociologist or even art historian or biologist. So network science is super interdisciplinary. However, its origins and the root of networks are coming from a very early age from the field of mathematics. So this story goes back to the city of Königsberg in 1736. In the city of Königsberg, there was a public puzzle which said that there is no way to walk across the 7 bridges crossing the river Prega, in a way that this walk only passes every bridge just exactly once. So once again, there was the city of Königsberg, there was a city that split it into a few parts, and there were 7 bridges across the river. And the idea was that there is no way to walk across all these bridges in a way that someone would cross every single bridge just once. Well, this sounds like a very serious problem for an urban planner or a transportation engineer. Not sure that these professions existed back in the day though. So anyways, the mayor of the city reached out to Leonhard Euler, one of the biggest mathematicians of all times, to try to ask for his help to figure out this puzzle. And Euler, as a mathematician prodigy should do, started to figure out the actual mathematical background, and by doing so and by answering this little puzzle, he invented the field of graph theory. So, almost 300 years ago, Euler laid down the foundations of graph theory, which even today uses the very simple structure. So a graph or a network is a set of nodes connected by links. So now that I uncovered the definition, once again, a graph or a network is a set of nodes connected by links. The definitions between graph and network are not that clear-cut. However, usually what I see is that people talk about graphs whenever it's an abstract construct, and once they start to fill it up with data, they will start to call it a network. So, we have networks and graphs which have the core structure of nodes connected by whatever links they have. And this has been the same for almost 3 centuries, and this is also what makes network science a true success story, because this simple yet complex structure is just so easily adaptable to almost any use case that wherever we go in life we will find networks sneaking around us. And here I put together a short collection on the different possible applications of networks, so let me just jump there. Oh, I'm always in the way. Let me just shrink myself to the bare minimum. So here I am. So what kind of network science applications are there out in the wild? So where would you see networks? Well, the short answer is everywhere, and the long answer, well, that's an entire book that I am currently translating from Hungarian to English, but here we have like a middle ground solution where I listed 15 different applications. In the description, I will also share links for each of these apps, by the way, so you can read up if you want to. And let's see, what do we have here? Just a few examples. In the times of COVID, epidemiology and epidemic networks are a very clear use case, because whenever we pass on the disease to a new potential patient, we are actually building a network connection, and we are part of a global so-called dynamic process on a network. So whenever a disease spreads across a society, there is a hidden network at work which is, via its edges, is passing through the viral molecules. When it comes to social networks, if we move on to the list, social networks are everywhere, from school classrooms to the giant social media apps like Facebook, Instagram, Twitter. They are all social networks. So we are really living in the era of social networks. I don't think that's a big question for anyone that there is networks behind. Then biological networks, maybe the best example there is our brain itself, which is a giant biological network, billions of neurons connected by axons and synaptic connections. But then also financial networks like the interconnected network of banks linked by all sorts of financial instruments that kind of also led to the 2008 cascading failure on the banking system. But if we move on, there is like the supply chain network. You probably remember the Evergreen, that ship that got stuck in the Suez Canal. That was a very great example on network vulnerability. And if we keep moving on, then you can find other things like energy network, or the network of scientists, artists, DJs, one of my favorite topic, or even fantasy networks, which is also very dear to me, from the Game of Thrones to the Witcher network. So there are many use cases out there about networks, and here I also put together a few examples from my own career, like the fictional networks, for example, Game of Thrones and The Witcher, a dog brain network that was a very interesting research with ethologists I worked on. Then we also mapped out the network of Nobel laureates and Oscar winners, or even NFT artworks, or the soccer players on the latest World Cup. So even these few examples illustrate very well, and now I will go back to normal size. So even these few examples illustrate really well that how widespread networks are in our daily lives, and why it's really crucial to understand what network thinking actually is on a daily basis. So that was it from me for today. Please let me know how you like this new format, and whether I should make more videos which are more like mini lectures or mini talks. And next time I will be back with some more Python. See you there. Bye.